So what I just showed you how to do was how to graph quadratics by making a t-chart. And making a t-chart with all those coordinates on it is a great way to graph quadratics, but it's not the only way to graph quadratics. And the way that I'm going to show you how to graph quadratics is by finding points called the vertex and the intercepts, and that is a way that you can graph them sometimes more quickly rather than making a t-chart. So let me give you an example. Of a quadratic that doesn't look the way you're used to. It doesn't look the way you're used to as far as graphing goes. Now, we've done quadratics like this during the semester, but we've never graphed any like this because every quadratic that we've graphed so far has looked like this. It's always been f of x equals, and then there's like sometimes a number in front, and then sometimes a number in the parentheses, and then sometimes a number on the end, something like that. It's got parentheses squared, right? With extra numbers sometimes. This one doesn't have that. But it would if we factored it. Now the problem is if we factor it right now, it's not really going to work out too well for us because, don't write this down, if I factored it right now, I would get something like x minus 6, x plus 2. That won't help me because it's not a set of parentheses squared. See that? So just factoring it like it is won't help me. How can I factor it in such a way that it'll be a set of parentheses squared? And it turns out we learned a way to do that too. It's called completing the square. That was not last week. That was last month. It's been a while. So here's how completing the square works. I'm going to rewrite this equation, except I'm going to replace the f of x with y, just because it'll look a little nicer when we're doing the algebra. I'll refresh your memory on completing the square. Completing the square, the first thing you got to do is get it where the x's are on one side and the numbers are on the other. So the first thing that we got to do to complete the square is to get this 12 moved over onto the other side. So we get y plus 12 equals x squared minus 4x. Okay, so here's the thing. I want to add or subtract some number on the end here so that when I factor the right side, it is a perfect square. What number could I put here where factoring it would cause me to have a perfect square? You've probably forgotten because you've slept since then, but the way you do it is you take the number in front of the x, divide it by 2, and, nope, nobody remembers, square it. So I need to add 4 to both sides. So on the left side, we have y plus 16. And on the right side, x squared minus 4x plus 4. That's completing the square. Please review that if you have forgotten. Cool. So now I know that the right side can factor into a perfect square because I set it up that way. There it is. Now that I've got that factored into a perfect square, the next thing I want to do is get it back to y equals like I had it originally. Y, or you can go back to f of x at this point if you want to. And that looks like the kind of thing that we have dealt with before. How's this going to differ from the parent function? What's the transformation that's going to happen here? What's the minus 2 going to do? If by left you mean right, then yes. 2 units to the right.
Oh, yes.
You probably meant stage left. It's to the right. And?
Down.
Down.
60.
Okay. That actually gives me a really valuable piece of information. It tells me where the lowest point is going to be. The point where this quadratic turns around and starts going the other way. Because the parent function is at 0, 0, right? The parent function turns around at the coordinate 0, 0. This one takes that 0, 0 and goes to the right 2 and down 16. So if I am at 0, 0 and I go to the right 2 and then down 16, where am I?
Off the grid.
Yeah, but what's the coordinate? It's 2, negative 16. Let me get a graph and I'll show you. I'm at 0, 0 for the parent function, right?
Go right 2.
I go right 2 and down 16, which would be like down there somewhere. That coordinate is 2, negative 16. That is now the lowest point. My parent function did turn around right here, but now I've taken this point and slid it down, so now the parent function turns around there. Okay? Why is that relevant to us? Well, the spot where the quadratic turns around is a really important point. It's a really important point. It's so important that we got a special name for it. It's called the vertex. Excuse me. The vertex is, I'm just going to write this in plain English. This is not the math definition, but it's the spot where it turns around. So if I had a quadratic going like this point right there is the vertex. Okay? Now let's go back to the graph that I drew. What I want you to notice is that although I stopped this graph short and drew the arrows, if I had continued drawing this graph like this, if I'd gone all the way up, this graph would have crossed the x-axis. It would have crossed the x-axis in two spots, right there and right there. Those are two places where it would have crossed the x-axis. Those are called intercepts, X-intercepts. We also sometimes call them roots. And sometimes they're also called solutions, depending on the context. The spots where they cross the x-axis, those are also really important to us. An x-intercept is a place where the equation, the y value, equals 0. So if I want to find where the x-intercepts would be, all I do is take the equation, and I'm going to take the original equation, x squared minus 4x minus 12. I'm going to take that original equation and set it equal to 0. What are the values of x when that equation equals 0? Well, I can solve that by factoring, and I already showed you how to factor it. X minus 6, x plus 2. And man, this is throwback. We did this right at the beginning of the class. So one of my solutions is 6, and one of my solutions is negative 2. So my intercepts, x-intercepts I should say, are negative 2, 0, and 6, 0. Intercepts and the vertex. We actually left out one intercept. Which intercept did we leave out? We left out the y-intercept. The y-intercept's really easy though. The x-intercept happens when the y equals 0. The y-intercept happens when the x equals 0. So let me find a blank spot. Here we go. The y-intercept is when the x equals 0. So I'm going to take the original equation and replace the x's with 0. Zero squared is 0. 0 times negative 4 is 0. 0 minus 0 minus 12 is negative 12. So y-intercept is 0, negative 12. Okay. I will take your silence as a wahoo, this is great. And I agree. This one's actually going to be pretty tricky because of the 3 out in front. You'll see in just a minute why that's going to be kind of bad. But let's start off with something really easy. The easiest way, or the easiest thing to do with these problems is the y-intercept. The y-intercept is the spot where x equals 0. So what's the y-intercept going to be? If I replaced all these x's with 0, what would I have? 1. I'd have 0 plus 0 plus 1. So before I do any math, I can tell you what the y-intercept is. It's 0, 1. Okay. So now let's work on finding the vertex. So to find the vertex, I want to take this and put it in that form where I've got the perfect square. If I factor it right now, I'm going to have a bad time. So I'm going to complete the square. I'm going to replace the f of x with y here at the beginning just to make it look a little simpler. You don't have to do that. You can work it out with f of x. It just looks weird. So to complete the square, I've got to get the x's by themselves. Let's do that. There we go. I can't complete the square when I've got 3x squared. I can only complete the square when it's just x squared. So I think what I'm going to do next is to factor out the 3 over there on the right side. There we go. That seems pretty good. What do you think? Okay, I wasn't really looking for a yes or no. I mean, how do I complete the square now? What number do I add here that will make this into a perfect square? As you will recall, you take the number in front of the x, which is 1, you divide it by 2, and then square it.
1.
So a half squared, what's a half times a half? No, that's a half plus a half. Half times a half is a fourth.
Oh.
Okay, now here's where it gets tricky. X squared plus x plus 1/4. Now here's why it's tricky. Did I really just add 1/4?
Yeah.
I did not. I know it looks like I did plus 1/4, but that is not a plus 1/4. How much did I actually add?
3.
That plus 1/4 is not really plus 1/4.
3/4.
It's really 3/4 because of this 3 out in front. This is 3 times a fourth. I actually add, when I put this in parentheses, I actually added 3/4. So over on this side, I gotta add 3/4. Man, you guys are rusty at completing the square. I know what you need to practice this week. Okay, so y minus 1 plus 3/4, that is y minus a fourth equals 3. Let's go ahead and factor this. It's x plus 1/2 squared. Definitely need to practice completing the square. The last step then is to get the y by itself again. So we're going to add 1/4 to both sides. So y equals 3x plus 1/2 squared plus 1/4. Whoo, lordy! Why did we do that? No, I'm really asking. Why did we do that?
It's torture.
Well, I mean, you being miserable is a benefit for me, but what piece of information can we get now?
How it will look.
Sure, but we were looking for the vertex. That's what we can get now. What's this half going to do?
Clear it.
It's going to move it how?
It's going to divide it. Shift it. Right? Shift it.
To the left 1/2 and
Up a quarter.
so the vertex is going to be negative 1/2, 1/4. That means the middle of this graph, if I folded the parabola in half, it would go through negative 1/2. Sometimes we call that the axis of symmetry. The axis of symmetry is like the middle of the graph. The axis of symmetry would be x equals negative 1/2. It's a vertical line going through 1/2.
Why did you change it to negative?
Because plus 1/2 moves it to the left. So if I'm at 0, 0, and I go left, I'm in the negative area. Okay, last thing we got to do is X-Intercepts, but I got some good news for you. If I was at 0, 0, and I went to the left 1/2 and up 1/4, there's where my vertex would be. Does this graph open up or open down? Up, because it's a positive 3. What's the deal with the X-intercepts?
There's not.
There aren't any. Does not cross the x-axis. So this is where we can tie in one of the things you learned with the quadratic formula. If I really wanted to know where the x-intercepts were, this would be my A, my B, and my C for the quadratic formula. If I plug that into the quadratic formula and solved it, what kind of answers would I get? They would be imaginary numbers. They'd be complex numbers because it doesn't have any real number x-intercepts. So when you did the quadratic formula and you got imaginary numbers, what you were saying was, if I graphed this, it would not cross the x-axis. So there's your fun little imaginary number trivia that I know you were waiting for. No? Just me? Okay, fair enough. What happens if it has a negative in front? What would happen, you guys? What's the y-intercept? Start with the y-intercept. That's the easy one. If the x's were all zeros, what would the y be?
0.
0 minus 0 plus 3. The y-intercept is 0, 3.
So if it's negative, it goes down. Or flips.
It'll open down. Yeah. It'll flip it. We're not really worried about that yet. Next, we got to find the vertex, and to find the vertex, you complete the square. Okay, so y equals negative x squared minus 2x plus 3. And the first thing we would do is subtract 3 on both sides. All right, let's complete the square. What number should be added onto both sides?
4.
No, I can't complete the square yet.
Oh.
I can't complete the square yet.
Because there's a number in front of you.
Yeah, there's a number in front of the x squared. What is it?
-1. You have to
Negative 1. I got to factor it. Good. I'm going to leave some space here to put that. Factor out of negative 1.
You can do 1x, right? Oh, wait, never mind. It's x squared.
I need to have the x in there for when I complete. You're right. I could do negative 1x, but I need the x's in there to complete the square. Okay, so now somebody said it just a minute ago. What's the number I have to add onto both sides? 1, but be careful. If I do a plus 1 here, am I really adding 1?
No.
What am I really adding?
0.
-1.
-1. -1 times 1.
Please explain.
Because when I put a 1 in parentheses and there's a negative out in front, it's really -1.
Oh.
So that gives me y minus 4 equals -1. Let's go ahead and factor it. X plus 1 squared. And then add 4 to both sides. So y equals, I'm going to drop the 1 and just do negative. You can keep the 1 if you want to. Here we go. Where's the vertex?
1 and 4. 0. -1 and negative. Wait, -1 and 4.
-1, positive 4. Very good. Which means our axis of symmetry, the line going right through the middle of the graph, is at x equals -1. Okay, now we got to find the intercepts, the x-intercepts, I mean. So I'm going to go back to the original equation. Negative x squared minus 2x plus 3, and just set it equal to 0. When I solve that, that'll tell me what the roots are. Now, I don't like that it starts with a negative, so I think the first thing I'm going to do is divide everything in this problem by -1. Just so it doesn't start with a negative. So that's going to give me positive x squared plus 2x minus 3, and then 0 divided by -1, 0. Yep. What will it factor into?
One and two.
-2, -1? No, -2, positive.
Three, -1.
Thank you. So, x plus 3 equals 0, x minus 1 equals 0. So my x-intercepts, or the roots, are -3, 0, and +1, 0. Okay. So I think undoubtedly the worst part of this whole process has got to be finding the vertex. Finding the vertex has got to be the worst part because that's the part where you have to complete the square. If you look at the work that we just did, like most of it was this completing the square stuff to find the vertex. If only there was an easier way that your teacher was going to show you after doing 3 really hard ones that took a long time. If only there was a simple, quick, easy way to do it, but surely not, because what kind of a monster would make you complete the square 3 times in a row, once with a fraction and once with a negative? If there was an easy way to go straight to the vertex, my God, what a monster that man would be.
I told you absurd.
So you will notice that if all I asked you to do was solve this problem, it would be an ideal candidate for the quadratic formula. Absolutely ideal candidate for the quadratic formula. What would A be? And B? And C? So the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. That was the quadratic formula, right? The b squared minus 4ac was an important part of the quadratic formula. What did the b squared minus 4ac tell us? What was that called? The b squared minus 4ac?
Quadratic formula?
That's part of the quadratic formula, but just the part inside the square root, what was it called? The discriminant. And what did the discriminant tell us?
If
It was an easier way to do it.
it's a positive,
Uh-huh.
2 real solutions.
Uh-huh. Yeah. How many solutions? Right? This part told us, do you have 2 solutions? Do you have 1 solution? Or do you have 2 complex solutions? It turns out that that isn't the only super important part of the quadratic formula. This plus minus here is important. What that plus minus means is take this piece right here and add and subtract it. Add means go a little bit to the right, subtract means go a little bit to the left when we're thinking about graphing. Go to the left and right of what? Well, this thing. That right there, the -b plus or minus 2a. I could separate the quadratic formula like this. I could do -b over 2a plus or minus the square root of b squared minus 4ac over 2a. Right? If I separate it into 2 different fractions, I could do it that way, right? This is saying add and subtract this much when you do the graph. Add a little bit, subtract a little bit, that gives you the 2 sides of the graph. Some on this side, some on this side. this side and this side of what? The middle. Which means this right here is the formula for the axis of symmetry. That is the middle of the graph, right through the middle of the graph. So if I look at this problem, I only need B and A, right? The B was -4 and the A was 1, so let's try it. Negative B over 2A. So that's +4 on the top, +2 on the bottom, so 2. The axis of symmetry is at x equals 2. But my question was, what's the vertex? Well, the axis of symmetry is closely related to the vertex. If you look at this problem, the x-coordinate of the vertex was -1 and the axis of symmetry was -1. On the problem in front of that, the x-coordinate of the vertex was -1/2 and the axis of symmetry was -1/2. The axis of symmetry is the x-coordinate of the vertex, so whatever my vertex is, I know it's got to start with 2. It's going to be 2 something. What's the something? What's the y going to be if the x is 2? Well, I'm going to take my original equation and replace the x's with 2. So it was x squared minus 4 times x minus 12. That's 4 minus 8 minus 12. That is -4 minus 12, which is -16. So my vertex is 2, -16. Okay, so let's check and make sure that we did that right. Hey, look, there's the first problem we did. X squared minus 4x minus 12, and the vertex was 2, -16. So negative b over 2a is a shortcut to find the vertex so that you can get there without completing the square. Now, why anybody would want to get there without completing the square is a mystery, because completing the square is one of the few things in this life that brings me joy. But if you're one of those people that just hates being happy and you don't want to complete the square, well, don't let me stand in the way of your dreams. Yes?
So all of these ways to do the problems are interchangeable?
Yes. Instead of completing the square, you could do the negative b over 2a to get the x, and then plug it into the equation to get the y. And that would be perfectly acceptable. Who's got questions?